Welcome to chemistry lover. So this is a very important question, and here you can see this particular compound. It is a derivative of furan. So it is treated with methanolic ammonia and then it is heated. So it is heated under sealed tube. So what will be the product? Now these four options are given here: A, B, C and D. So you have to predict the correct answer. So although the problem looks simple, but it is not as simple as that. You have to work out the mechanism, otherwise you can't get the correct product. So let us draw the molecule. So this is our molecule, and here we have this carbonyl group. So first, if we look into these four options, you can see all these three options. The main skeleton of the molecule is same, that is the furan ring, but only in this option it is changed to the pyridine skeleton. So the three options are similar and one option is quite different, but from this perspective we cannot tell the correct answer. We have to work out the mechanism. Now you can see this sheep space, it can form just by adding NH3. So if NH3 attacks over here, you know that condensation between a carbonyl group and amine will give you sheep space, and this sheep space can indeed form. But at the same time you have to understand that furan, this oxygen is quite electron pushing, and it always push electron into this carbonyl group. So that means this carbonyl group is not that much electron deficient, and its reactivity is reduced. So its reactivity is reduced, it is less electrophilic, but sheep space can form. But you can see this is heating condition, and methanolic NH3 means it will contain some amount of water. So in this heating condition, I don't think that this sheep space product will survive. So we can we can keep it as one of the options, but it is not a good option, and this doesn't look like a product, right? So let us see what else can happen. And you can see this electron pushing means this position is not that much electron rich, it is actually electrophilic center. Okay, so what I am trying to say is that in the ground state also you can see any nucleophile can easily attack over here. So if a nucleophile attacks over here, this is how the negative charge will directly go to this carbonyl group. Or if you take the other resonating structure like this one, then also you can see any nucleophile can easily attacks over here to give you this. Okay, so this is quite good, and that's why this position of furan is electrophilic. Okay, so this is like a 1,4 versus 1,2 addition. This is direct addition, this is 1,4, in this case it is 1,6 addition, and here 1,6 addition will be favored because this position is less electrophilic because of this oxygen push. So we can understand that the ammonia will more likely attack in this center. So if this happens, what we will get? So we will get this one, NH2, here hydrogen, and here we will have this OH and this. Okay, now you can see this particular point, this carbon center, it is a tetrahedral intermediate, so it is a TD intermediate. That means it will collapse, it is not stable. Now it can collapse in two ways. So basically both will give the same result, but we can show it in two different mechanisms. One is this oxygen can push, this bond will go here, this bond will go here, and this will open. So that will give you something like this, NH2, and here you will get, so here you have this O minus, and here you can see this new carbonyl group is formed, and this another way to break this tetrahedral intermediate is just this nitrogen lone pair can push, and this can open, so that will give you this NH2 plus, and now here in this side you will have this O minus, this here you will have this OH and this, and finally you can see it can again tautomerize like this. So if it goes here, then if this bond goes here, this bond goes here, and it will go to there, and you will get the same intermediate, right? So from here also you can get the same intermediate. But another interesting thing is, if this one doesn't go in this pathway and this oxygen lone pair push indeed, so then you will have protonation from this side, and from that you can get something like this. So here you have this NH2 plus, here you have this carbonyl group formed here, and this, and now you have this, sorry, here you have this this OH group, and this this thing like this. Okay, so this thing can form, and you can see from here you have a possibility of 1 2 3 4 5, sorry, I did some mistake. Okay, so this is like, let me rewrite it again. So it is like, you have this double bond over here, you have this carbon and this NH2, it is actually in plus form, NH2 plus, and here you are forming a carbonyl group, this one is forming carbonyl group, and here you have this OH and this. Now it is 1 2 3 4 5, so you can see there is a possibility of 5-membered ring formation. But at the same time you can see, if this nitrogen loses one hydrogen also, then also it will be in sheaf space form, and this sheaf space, it is not that much electrophilic so that it can attack over here. So if it attacks over here, then again this positive charge will come over here. But finally it can like you can see, finally it can go to the neutral form, and here you can see, so this here you have, and here you have this OH, this OH and this. So this is one thing which can happen, but this is quite less favorable, because this attack is not that much favorable, because this is sp2 nitrogen and it is not that much electrophilic. But if it goes through this pathway, you can see the other pathway, then these two can easily cyclize. So if this cyclize, what will happen? So you can see this will give you this O minus over here, and a double bond will form here, and this. So this is basically condensation between this NH2 group and this carbonyl group. So this will give you this product, and you can see this product is actually which one? This D. So D is the most logical product which can form over here, and from there also you can see, if you consider this one, so what we can get something like, so actually here you cannot make this ring aromatic. Okay, so that's why you are not getting this product, because you cannot aromatize this ring. And if you talk about this product, there is no possibility, because this is quite weird product, and you can see this methyl group from here, it is shifted to here, and this looks quite impossible. So the most probable product is option D. So option D will be the correct answer. I hope that you get the idea behind this question. This is quite complicated question. I hope that you understand. Thank you for watching.